and welcome to the newest installment of Dave Does Precalc at Home. Today we're going to get into section, I forgot the number already, I'm too lazy to look it up. I think it's section 7.5? Maybe it's 7.3. I don't know, 7 point something. I'm going to guess 3. This video is off to a great start. Whatever section this is numbered, I'll get the number right when I upload this to YouTube. Whatever this is numbered, this section is about polar coordinates. And to do this, I'm going to start by asking a question. If I draw a circle on the coordinate axes, let's say this circle has a radius of 6. And then I draw an angle somewhere in this circle. I'll do this one. This is a 30-degree angle. It's the same as in radians, that would be pi over 6. This point on the circle that is 30 degrees off the x-axis on the circle of radius 6, this point has some coordinates. It has x and y coordinates. So the question is, what are those coordinates? That's what we're going to start with today. How do I find the coordinates if the only thing I know about this point is the radius of the circle it's on is 6 and the angle off the x-axis is 30 degrees? To do this, we're going to come back to the unit circle. If I make a unit circle with a radius of 1 and put a 30-degree angle in that, 30 degrees, I know that the coordinates of this point are going to be root 3 over 2, comma 1/2, because of the unit circle. I have this information. This is just readily available to me. So the difference between these coordinates on my circle of radius 1 and these coordinates on my circle of radius 6 should just be that these coordinates are 6 times larger. So I'm going to say that this x coordinate is 6 times root 3 over 2, and the y coordinate is going to be 6 times 1/2. So this will be 3 root 3, and this will be just regular old 3. So these coordinates are 3 root 3, comma 3. Lots of 3's going on. Not my intention. Happens sometimes. This is the process for how we're going to find coordinates, x and y coordinates, given an angle and a distance. Let me do another example, and then we'll talk about what this is going to get used for. Maybe I'll do 2 more examples. Let's make a circle. Let's have this one have a radius of, I'll go with 13. 13 seems fun. And I'm going to do theta is 4 pi over 3. This seems like a good angle. 4 pi over 3 with a radius of 13. The process for finding the xy coordinates of this point, which is what I want, they're going to be almost exactly the same. First, I'm going to look at the unit circle. I'll find 4 pi over 3 on the unit circle, and I'll see that the xy coordinates of that point on the unit circle are negative 1/2, negative root 3 over 2. Once I have the unit circle version of these coordinates, these are the coordinates if my circle had a radius of 1, because it's a unit circle. If I want the coordinates of this point on this circle of radius 13, I just have to multiply these things by 13. So my x coordinate should be 13 times negative 1/2. My y coordinate should be 13 times negative root 3 over 2. So this will be negative 13 halves. This will be negative 13 root 3 halves. Once again, lots of 3's. Maybe I'm just subconsciously thinking about 3's today. This is the general procedure. Find x and y coordinates using your unit circle. Multiply them by the radius of your circle. We can actually generalize this using symbols, if we're feeling very brave about symbols. Generally, given radius r and angle theta, we can find the x, y coordinates the x, y coordinates by x equals, going from our other two examples, we always took, it was the radius multiplied by the x coordinate on the unit circle. And the fancy way to write the x coordinate on the unit circle is cosine theta. And y is the radius times sine theta. These two equations are going to be extremely important for this section. Put them in your notes, make sure they're easy to find, make sure that you understand them. You're going to see a lot of them. X is r cosine, y is r sine. This is how we extend the unit circle into bigger circles or smaller circles. Sometimes you'll want to look at this and r will be like 1/2 or something. So generally this is a way we can find x and y coordinates for literally any angle and radius given to us. Sometimes this is going to get a little weird. Sometimes people will ask you to find the coordinates of say theta equals 5 pi over 4 and r equals negative 12. This can get goofy like this. There's nothing saying the radius has to be a positive number. It doesn't even have to be a whole number. Negative 12 is fair game here. So here's what this means. If we're looking at a circle, first we're going to find 5 pi over 4. 5 pi over 4 points into the center of quadrant 3. So this is you finding your direction. If you're thinking about this, think about this in terms of a direction and a distance. If you start on the origin, the first thing you need to do is look at your angle and rotate yourself until you are pointing in the correct direction. In this case, we want to be pointing directly into quadrant 3. This is 5 pi over 4. If our radius is negative, that means we're going to face quadrant 3 and walk backwards, which would put us into quadrant 1. So this is what that means theoretically. When I do my x and y coordinate calculations, I should expect my x value and my y value to both be positive in this case. Because if I point into quadrant 3 and go backwards, it should put me in quadrant 1. That's the goal here. Let's see if it actually works out that way. X equals r cosine theta. R is negative 12. Cosine of this is negative root 2 over 2. So this, after I simplify, should give me positive 6 root 2. It's a positive number. That's what I was expecting. So far, so good. Y equals r sine theta. Once again, r is negative 12. And once again, the sine of theta is negative root 2 over 2. It's the exact same value there. So this should also give me 6 root 2, positive 6 root 2. So I'm getting positive x and y coordinates, which means I should be in quadrant 1. And theoretically, if you're pointing into quadrant 3, but then moving backwards, that should also put you into quadrant 1. So this checks out. The math checks out here. So these set of equations we have, x equals r cosine theta, y equals r sine theta. This is a very reliable, very, I'll say robust. It's hard to make these things break down. You can put in goofy, weird numbers. You can put in r equals 0 if you wanted. You can put in r equals fractions. This will always give you accurate, correct coordinates, whatever kind of weird nonsense you use for r and theta. No weird nonsense going on. It's good. That's how we get x and y values out of this. I'm going to cut the video here so that I can move on to talking about what happens if we try to do this backwards, because that's a much bigger conversation. Hopefully you transition right into the next one and I don't have to say goodbye or anything.